So let's look at problem 16.41 at the back of chapter 16 to help us practice what we've learned about reactions of amines, which are bases, and reactions of quaternary ammonium cations, which are acids. So it asks us to complete the following equations, which means determine what the products are going to be. And what you want to do is remember that these are all acid-base reactions. So identify the acid, identify the base. The acid will donate a proton to the base, or the base will accept a proton from the acid, however you want to think about it, and then you'll get your product. So you want to balance the atoms on each side as well as the charges on each side. And they don't have to be zero on each side, they just have to be the same. So pause the video and see what you get. Okay, so let's look at problem 16.41a. On the left-hand side, we have an amine reacting with HBr, which we recognize as a strong acid, and we know that amines are bases. So the amine is our base, and HBr is our acid. And just for fun, let us name this. This is a secondary amine with two different alkyl groups, and the cyclohexyl group has more carbons, so that's going to be sort of the root name. So this is going to be, the name of this is N-ethyl cyclohexylamine. Alright, so for the acid-base reaction, our acid will donate a proton, H+, to the lone pair on the amine nitrogen. So our products will show that. Our nitrogen in the amine now is bonded to this H+. The proton keeps its positive charge as it leaves the acid. And then we have the bromide, which was the anion of the strong acid. So on the left-hand side, our amine is not going to be soluble in water, but once it reacts with acid, an acid is going to form this ionic compound, which is soluble in water. Alright, so 1641b. I have a quaternary ammonium cation that has a hydrogen directly bonded to the nitrogen. So I know this is an acid, and it's reacting with hydroxide, which I know is a base. So my base is going to accept a proton from my acid. Let's see what that will form. So hydroxide, when it accepts a proton, forms water. And when that quaternary ammonium cation loses its proton, it forms the neutral amine, which we know as aniline. And then the bromide is still there. So let's look at our charges on both sides. Our quaternary ammonium cation with the bromide has an overall charge of 0, and then hydroxide has a charge of -1. And on the product side, I have two neutral products and a bromide with a -1 charge. So on the left, I have an overall charge of -1, and on my right, I have an overall charge of -1. Now, there is a cation in solution somewhere. It just hasn't been expressly written. Alright, now let's look at 1641c. So we have another amine here, so we know that's a base, and it's reacting with hydronium, which we know is an acid. And just for fun, let's name this amine. Ethyl is longer than methyl, so this is going to be N-methyl ethylamine. And our amine is the base, and it's going to accept a proton from our acid. So on our product side, our amine nitrogen now has one more hydrogen and a positive charge. And when hydronium loses that proton, it loses that H+, it forms water. So if you got these right, pat yourself on the back, and if you didn't, it's all right. It'll just take a little bit of practice in identifying what the acid is, what the base is.